Settle for the next round? You want to start that?
Yeah.
Settle, you got power?
Fine. Go for 15 minutes more. That will be fine.
Go to the next round. All right, this is the fun stuff. The arrow veins. All right, what's so special about arrow vein? Humans have been shooting arrows with feathers on it since the time of the caveman. Why is arrow vein such a unique and distinctive piece that we pay so much attention to as a company? First, this is a recall of Professor Selig. Yes, we have used feathers since the time of the caveman, but humans barely learned how to fly for 100 years.
Yeah.
Birds don't fly with feathers. Birds fly with wings. What do we put our arrows? Feathers. This is first time ever we put wings on our arrows. That's the big deal. This is not a guiding system. It's a flying system. That's the key between arrow vein and every other single vein in the market, because it's actually a wing. Now imagine this, assuming if this is an airplane wing, what does it look like? It's a delta wing, isn't it?
Yeah.
But with a tailing edge. What are the downside of a delta wing? Especially with such huge frontal area. This thing, if it is really a wing on an airplane, the moment the airplane flies, it will behave like this. In other words, the lift factor of this wing is so serious. A normal vein at a curvature may have maybe 500 Ronalds, which is a lift characteristic, which doesn't exist, because just like the left turkey feather with the right turkey feather, that's a little bit. That's about 500. This wing have 72,000 Ronalds capability compared to a left or right turkey feather. Think of the percentage difference change.
A lot.
It's ridiculous. Technically, with the wing profile and design, the total lift characteristic is like this. It's like throwing a Hercules wings on an F-16. That's how ridiculous it is. Basic specs. A normal Blazer bling going through 20 yards of air will spin between 2 to 3 turns. That's a 300 feet per second on a normal projectile. Want to make a wild guess how much arrow vein 2 turns?
16.
60. 60. Remember I teach you yesterday?
Yeah.
But except you turn it reversed. It's 60 times.
60.
It's 29 times 60. And the arrow vein 3 is closer to 120. The moment you have those numbers sink in your head, it's a hell of a difference.
Yeah.
How come it's so different? What are the benefits and what are the downside? This is what the big deal is. See this frontal area right here? This area right here is one of the most important factor of the arrow vein. This curvature right here. The aspect ratio of this curvature is 100% identical to a barn owl, a North American big barn owl. What's the benefit of an owl when you fly in air? There's no sound.
Quiet.
A fun fact, do you know no deer or animal ever jump strings?
I would believe that.
They don't jump string. Guess what they're jumping?
The arrow.
They're jumping the vein and the broadhead. They're not jumping the string. Because it's proven again and again and again, the sound that is a distance from a deer, do not alert it unless it's metallic. But when you got a sound that's coming towards them and get louder and louder and louder, it alerts it to no end. That's exactly what happened. So the first thing we did is that we created a vein with no sound. Second, if this is an airplane, it's flying, what is this wing fighting against? Gravity,
Yep.
right? But when you have veins like this, spinning in the air, What is the vein fighting against?
Gravity. Pressure again.
Absolutely nothing. When you got circular lift, that's fighting against nothing. What do you think it's going to do?
Fly
The
faster.
more it flies, the faster it go, and the faster it go, and the faster it go, until we hit diminishing return. Because at that moment, the air is pushing against this. But then we, with Professor Selig's help, we are very, very fortunate to learn about one very good phenomenon. It's called the aerodynamic elasticity memory. What we did is that it's actually using what Professor Lely have started. The moment when this vein being pushed to the point, it's spinning so fast, it's not fast enough. This is being pushed up. At the same time, this is being pushed down concurrently. What do you think it just happened? This vein have just find its most optimum of the angle of attack and reduce its leading edge. Which means that this vein is no longer just stupid. It is actually an intelligent vein. It will now based on the characteristic of the plastic, which is called the ISO factor. So slowly it turns, it will flex itself and find the angle of attack to find the optimum. So this now will now have the impeller effect while it turns. 90% of the vein, when you have high speed turn, guess what happened to the vein? It starts doing this. Flutter. That's the reason you hear so many veins. Since the feather is noisy, you know what feather is doing? It's fluttering. What the blazer doing is fluttering. Because when the air on both sides is even, if there's any disturbance, it will cause the oscillation of the material itself. That's what you call fluttering. The aero vein itself, if you take a closer look, this is where Professor Smith helped us. It's actually a super thin pyramid.
Yep.
Just like everything else. The moment you got a piece of paper, you flat this. But the moment you put it into a pyramid form, it don't. The material is the same amount, but the structural integrity is significantly changed. And that's the reason the location of material is so critical for AeroVing 2 and AeroVing 3. You can see that this will actually behave like this.
Yeah.
So the angle of attack is lower, isn't it?
Yep.
The release of the angle on the vortex is coming from the back is released. What do you think it's going to do?
Reduce the fluttering.
Have zero fluttering, have perfect flow, and you also see when it turns this is hitting the wind the wind coming in, the right side, it's also moving forward. But the moment when the wind goes like this, what does it do? It now goes into the wind like a drill.
Yep.
And since it's now not fighting against gravity, and it's lifting as it goes forward, then the most effective rolling surface known to mankind is air bearings. What's this arrow going through? Air. Now you know why all of a sudden the arrow goes such high speed with these ridiculous conditions. What are the downsides using AeroVing 2? Now I'll give you a little bit of history. When we first made AeroVing 2 revision 1, we designed it to be the absolute optimum, just like the picture diagram in front of you, except one difference. The left side and the right side texture is not the same. Because we want an absolute optimum efficiency all the way through. But we do not know that we step on some other people's pattern. Some people actually have a pattern saying the right side and the left side cannot be the same. So, but at the same time, AeroVing 2 first version was so efficient, it's pushing 90 revolutions per second, per 20 yards. It's too much. Most people cannot handle the capability of the vein. So the bad thing actually turned out good thing for us because we were forced to go back to our original mode. We resurfaced the mold. When you surface a mold, what happened? You make the mold wider, which make the vein thicker, which make it less aerodynamic efficient in the elasticity memory. It dropped close to 30% or 50% on its rotation ability to 60. But actually for us, it's so much better because all of a sudden, people using a Bissenberger with a sinus conversion within 1.5 degrees, it worked. And it also able to handle majority of the broadhead that is based on offset center design. Think about it. We got a vane that is too fast and nothing works. Nobody can fletch it.
Yeah.
Now by making it thicker, most people with the old bits, being careful with some reasonable broadhead, it will fly. That's the reason AeroVing 2 began to take off in 2009. And most people will hunt with it, love it, because when they shoot with it, when they go through air, there's no sound. Think through that, how important is that? That means if you miss an animal, it would not know it was being shot at.
Exactly.
Then you can get a second and third shot until it's too late. Now, how much you would pay for a second shot when the deer is still in front of you?
Any amount.
Exactly, and that's exactly how I feel too. Now, because of the AeroVing 2 being so fast and because of our original AeroVing 2, we found out there's no jig that will work with it that good. That's the reason we found it in 2009 January, we introduced AeroVing jig. But the moment we introduced AeroVing jig, we already know how efficient AeroVing 2 is. But at the same time, with Professor Selig's help, we know the magic that we have done is not even scratching the surface. So we already stepped into AeroVing 3 with the introduce of the AeroVing jig. We waited 3 more years to let AeroVing jig to be in the market. Then we introduced AeroVing 3. This is a superbly interesting vein, isn't it?
Yep.
What does it do that is so different from all the other veins? Now, just like we go back to the AeroVing 2, so we tell you a few more other very interesting characteristics of AeroVings. On a usual vein like a blazer, when it's an offset, when it's turning, what's it doing? It's interacting with air, right? When you push air, what happened? The more air you push, the more air you affect. The column of air that you affect is called the crosswind signature. That means when this arrow going through the wind, how big a column of air does it affect? This is some basic information which we find out to be amazing. Okay? A blazer and 2.5-degree offset, when they go through air, the column of air effect is about 9 inches.
Really?
That means this big a column of
Yeah.
air is affecting it. What does that mean when the wind is blowing? You got a 9-inch column that is being moved. How good you think its ability to buck wind?
Not very good.
Now, go to quick spin. It's closer to 12 inches.
3.
AeroVing 2, guess how much wind is affecting?
3.
That's how big. Because what is it interacting with? The air right in front of it, behind it, and flow out.
Yep.
The flow out is this much. So this is your column of air that you're affecting.
Yep.
So how good you think this is to affect by wind?
Great.
When the wind blow by it, this is how big that is.
Yeah.
Now 99% of people keep on going to the hype of saying, oh, I need an arrow shaft that's thinner so it won't affect by air. The moment you understand this theory, what's the shaft diameter size? Have nothing to do with anything. And flying an arrow, you can have arrow this big. Using AeroVing, the thing is only this big compared to a blazer of 9 inches. And that just change the whole thinking?
Yeah.
So people say, oh, I got a triple X shaft this big with veins on it. It's this much vein. If you put AeroVing on it, even on a triple X, which is the biggest known arrow shaft, put an AeroVing on it, it's only this big. If you shoot an injection with say quick spin on it, it will be this size.
Yeah.
So what's the size of the shaft with crosswind? Nothing.
Huh.
Isn't that funny?
Yeah.
The moment you understand it, you change the whole concept. What's important? But that said, thin shaft do have its ability to penetrate. It's just like if you are able to make a very solid piece, a thinner nail will go deeper than a thicker nail. That's a fact.
Yep.
But so if you just shoot targets, a thick arrow, thin arrow, what would you pick? A thick arrow with arrow wing on it. Because now you have all the wing bucking capability without losing anything and you'll be more durable. Now, that said, why would we still, then after we learn all this, we go into AeroWing 3. What's so special about AeroWing 3? First of all, it is designed in ground zero. We'll utilize the aerodynamic elasticity memory to the optimum. Second, you notice it's got a winglet on it, which means there's zero flow out. You can't, because all the flow out are blocked. And when you flex, see that? It actually gets stiff when there's high.
Yeah.
You know, in mathematics, AeroWing 3 is about 350% more efficient than AeroWing 2. Which, by theory, if AeroWing 2 spins 60 times, they should be doing 200.
Yeah.
But the fact is that unfortunately we have to deal with the fact is that there is still a certain limiting factors like plastic,
Yep.
like the capability of interacting with air. This only end up to be 120 to 150, which is still quite impressive if you think about it. But the most impressive part is the crosswind signature. It's this big. On a shaft of this size.
That's insane.
Now you know why this thing would go through air like it was out of style.
Yeah.
Like it doesn't exist.
Like broadheads can't hold up to it.
Exactly. That's the bad part. Most broadheads are not designed for it. But I did the research, and very shortly yours truly will give you more broadheads. So also bring to one thing. When you have vanes that's spinning in this condition, what are the biggest problem besides broadhead to make an arrow fly? The concentricity of every component. Which will lead to our next session. Do you know that every single component in the entire archery industry, none of them have that in mind? None. That means when you build an arrow, you pretty much guarantee it's a crapshoot, from front to back. None of them is concentric. Then how do you expect it to spin?
Can't.
Some basic stats. Do you know when you get 1,000 blazer, what's the maximum variance of that 1,000?
Not too many.
6 grain is what the blazer weighs. It can vary from 7 grain to 4 grain.
That's pretty nuts.
And you have 3 of them on the blade.
Yeah.
AeroWing 3, the weight variance is 0.07 grain. AeroWing 2 is 0.13 grain.
Jeez.
From any package in any color. Compared to average 2 grains.
Yep.
What's the variance?
None.
It's non-noticeable. Now we won't, just before we go into it, since we're at AeroWing, I want to talk about the AeroWing jig.
Yeah.
The AeroWing jig with the AeroWing is where make the whole thing possible. Because see, it is with an airfoil, how precise you need to put the vanes on.
Very.
Do you know what's the variance on a Bissenberger jig is? The best condition, best luck, with the best person is around 3 degrees. The worst case scenario is 17. Those are actually documented and calculated.
Yeah.
Very simple. Let me just show you one to see how far off it is. Even on a basic GNAC, this is what's inside the Bissenberger 1mm slot.
Yep.
How much do you think that is?
A lot.
Okay, that's your starting point.
Yeah.
At the same time, you know the Bissenberger is not 120, 120, 120. It's 120, 118, and 122.
Huh.
So how off are you?
A lot.
Now, when you go to airfoil like AeroWing 2, we know as a fact, the worst case scenario, you need 1.5 degrees. That's 3 to 17.
Yeah.
How do you expect this to fly?
Can't.
You just cannot. Of course, people say, well, I can make AeroVing 3 feels pretty good on my beds. It's like saying, you know what, I can slap some tire on the Indy sports car, it'll be okay to run.
Yeah.
As long as I don't go over 60 miles per, maybe 30 miles per hour. But why do it in Indy?
Yeah.
AeroVing 3, we know as a fact, based on calculation, this cannot exceed a quarter of a degree, or else it's not going to function right. Which brings us back to AeroVing jig. We tried our best with bits, doesn't work. We even team ourselves with the sinus conversion out of sinus archery using a Bissenberg conversion. With that kit, and with his help, I'm able to launch AeroVing 2. Because I don't have anything at that moment.
Yep.
With the AeroVing 2, with the sinus upgrade to the Bissenberg conversion, at least you are within 1.5 degree. So now you can get AeroVing 2 to work. But the moment you love the performance of AeroVing 3, there's really no other choice. You have to get our jig. But now, at the same time, why is getting a jig so critical? Well, if you cannot control the vane. Now you notice the vane is precisely made already, 0.07. If you look at a Bissenberger clamp and a Bissenberger jig, the moment when the clamp and the jig connect to each other, there's all kind of slop in it. How do you control the glue? Do you know that if you use an AeroVing jig using our glue, the moment you put the vane on it, we pretty much will guarantee that glue contact surface is around 0.03 grain of glue. Which means that the maximum variance on each AeroVing is 0.1 grain.
Yeah.
And the worst case scenario, with 2 of them off, your total center off is 0.175 grain. How bad is it? Compared to each vein being 2 grains off and throwing 2.5 grains of glue on it. The numbers are just so wide, isn't it? To the point you just think about, what am I really doing? And I do ask myself that question because I used to be one of them. This also brings us back to the concentricity of the vane, the shaft, and the connections, which will lead to our next session about the aero components. Okay, I'm done.
When are you gonna make purple ones?